Hi everybody, welcome to the first lecture of Electrical Engineering 331. In this lecture, we will discuss signals. Let me actually come up here and change this. Okay, so as I say, this is lecture 1, and in this lecture we will study signals. And in particular, this lecture will cover the material in your book up to the end of section 1-2. Now, it doesn't cover every single thing that is mentioned in the textbook, and so I encourage you to read up to that point, but the points that I'm discussing here are the points that might appear on a daily test or a midterm exam or a final exam. In other words, I think that these are the most important points in those first two sections. So today we're going to cover two different examples, and I encourage you, as you're working through these examples, to stop the video frequently and see if you can complete the work on your own without looking at what I've done, and then resume the video and see if your work matches what I have done. And once again, I want to repeat that the kind of problems you see in these two examples that we're going to work are very indicative of the kinds of problems you would see on daily tests or the midterm exam or midterm exams or the final exam. So let's go ahead and start with example 1. And what example 1 says is suppose that x of t is given by this. X of t is a signal that's equal to 0 for t less than 0, is equal to 1 for t between 0 and 1, and is equal to 2t plus 1 for t greater than 1. Now, if you wish, if it helps you have a greater insight into the problem, you can go ahead and graph x of t now, but that's not really necessary. In fact, just to be honest with you, just to be completely honest, it's not necessary to graph x of t at all. However, we will graph x of t at the end of this problem in order to see what happens to x of t as a result of what we're doing here. And what we're doing in particular is we're going to ask ourselves, well, if this is the expression for x of t, what will x of 2t minus 3 be? Now, if you look in your textbook, it talks about different ways to look at this kind of situation. And those, different people learn in different ways, and it might be that looking at that explanation will be the best way for you. So I certainly encourage you to look at the explanation in your book. But I'm going to present to you the way that seems to me to be the simplest way to approach this, and a way that in the past I have seen many students like. So let's see how it would go. Well, the idea behind this solution technique is very simple. If you compare what we have to what we want, you see that the only difference is here we have x of t, and here we have x of 2t minus 3. So it's just as though we have substituted for the t, we have substituted 2t minus 3. And that's exactly what we want to do in order to evaluate this function. In other words, we're going to take this expression for x of t, and everywhere we see a t, we will simply substitute 2t minus 3 and then proceed. So that's what we say. This is the idea of how we solve it, is we replace t by 2t minus 3 and then proceed. So let's see how this will go. Okay, so here we have replaced the t in the argument of the function by 2t minus 3. And then you see that we have also replaced every t over here on the right-hand side where we define x. We've replaced every single one of those t's by 2t minus 3. In particular, we replaced this t by 2t minus 3. We've replaced this t by 2t minus 3. We've replaced this t by 2t minus 3. And finally, the t right here has been replaced by 2t minus 3. So notice that this is 2 times t plus 1. So now it becomes 2 times the quantity 2t minus 3 plus 1. Now that we've done that, what we want to do is to simplify. Let me say another word about what I mean by simplifying. You see, if we wanted to graph x up here, it would be very easy for us to do that because we have x as a function of t. And for the different intervals on the t-axis, we know exactly which expressions to use. And we will find out in just a few minutes when we graph this function that it's very easy to graph it because of the way that we have gotten everything here in terms of t. But notice that that's not the case any longer. Now that we have substituted 2t minus 3 for t, we have these awkward expressions which would make it difficult for us if we wanted to graph this function, which is frequently what we want to do. So what we want to, our next step is to try to simplify and to get each one of these domains back in terms of t like they are up here. And so let's see how that will go. Okay, so we go to the next step. We'll just bring down the x of 2t minus 3. We bring down the 0. We bring down the 1. But now for this expression, we go ahead and do the math. So 2 times 2t will give us 4t. And then 2 times negative 3 gives us negative 6. And then plus 1. And then we bring down the word 4 in each case. And now, as a first step in trying to get these domains expressed in terms of t rather than in terms of 2t minus 3, what we do is we say, well, the condition 2t minus 3 is less than 0 is exactly the same as the condition 2t is less than 3. In other words, what I've done is I have simply added 3 to each side of this inequality. So 2t minus 3 is less than 0 becomes 2t is less than 3. Now for the next one, well, I will add 3 to each term here in this inequality. So the 0 will become 3, 2t minus 3 simply becomes 2t, and 1 becomes 1 plus 3, or 4. And then finally, with the last inequality, I add 3 to both sides of that inequality. And so 2t minus 3 simply becomes 2t, and 1 becomes 1 plus 3, or 4. Okay, so now if we look at where we are, I think you will admit that we have made some progress. Certainly this expression looks simpler than what we had here, but we still aren't all the way home. That is, these different parts of the domain are still not expressed in terms of t, they are expressed in terms of 2t. And likewise, we would like to go ahead and combine these terms as well. So let's go one more step and see what happens. Okay, so again, we bring down the x of 2t minus 3, and 0, we bring that down, we bring down the 1, and now 4t minus 6 plus 1, well, the minus 6 plus 1 can be combined to be minus 5, so we have 4t minus 5. Then we bring down the word 4 in each case. And then finally, in our goal now, remember our goal is to get everything in terms of t. Well, it's really quite simple to do that now. All we have to do is to multiply each side of this inequality by 1/2. So 2t times 1/2 becomes t. 3 times 1/2 becomes 3/2. Likewise here, we want to multiply through all the way by 1/2. So 3 becomes 3/2. 2t times 1/2 becomes simply t. And 4 times 1/2 becomes 2. And then finally here again, we will multiply by 1/2. So 2t times 1/2 becomes t. And 4 times 1/2 becomes 2. And let me point out one other thing to you now, that it was not an issue up here. In going from this step to this step, you will remember that what we were doing all the way through was adding 3 to each side of the inequality. And you all know that when you add a number or subtract a number from both sides of an inequality, it does not change the sense of the inequality. In other words, this less than sign stayed a less than sign, this less than sign stayed as a less than sign, this less than sign stayed as a less than sign, and this greater than sign stayed as a greater than sign. So nothing was changed, and it never changes in the sense of an inequality. Never changes. Oh, I'm sorry. I should have been comparing here and here. Everything I just said is correct, but I should have been comparing here and here. So again, this less than sign stayed as a less than, this less than is here, this less than stays here, this greater than stays there. Okay, so now, and so as I said, the sense of an inequality never changes simply as the result of adding or subtracting the same number to both sides of the inequality. So that's, I think you all know that. But when you multiply, the sense of the inequality can change. And when does that happen? It happens when you multiply both sides of the inequality by a negative number. But remember here, in going from this step to this step, we were multiplying through every inequality by 1/2. And so 1/2 is a positive number, and therefore none of the inequalities switched. So this less than stayed as a less than, both of these less than signs stayed as less than signs, and this greater than stayed as a greater than. Now in our next example, we will see what happens when we multiply through by negative numbers. But for right now, just remember that when you multiply through by a positive number, it does not change the sense of the inequality. So this is where we arrive after we do that. And notice that we now have reached our goal. Each part of the domain is expressed in terms of t alone, and it would be very easy now to graph this function. And in fact, that is what we will do. We will graph it to see how x of 2t minus 3 compares to the function we started up here with, x of t. And so let's see how that goes. Okay, well here I have drawn two graphs. So I drew them both on the same scale so that we can get a good idea of what's going on. And I have drawn the graph of the original function x of t here in blue, and you can see I've repeated the expression for x of t since it's above and not easily seen. Now I didn't put down the expression for x of 2t minus 3 because it's right here. But I'm going to graph x of 2t minus 3 in red. And so here are the two graphs. And let's make sure it's clear how each graph goes. So first let's look at the blue graph. Okay, so the blue graph says that x is equal to 0 for t less than 0. And so you can see over here to the left of 0, the blue line stays flat at 0. Then it's equal to 1 when t is between 0 and 1. And sure enough, when t here is between 0 and 1, you can see that this blue line is here. Now, notice that the increment on the vertical axis is 2, so this blue line is halfway between 0 and 2. So that looks correct. And then finally, it says that it's equal to 2t plus 1 when t is greater than 1. Okay, so this is the only thing where we might have to be extra careful. Okay, let's think about this. At t equals 1, which is where we start using this definition, because it's this expression is valid only for t greater than 1. So let's say at t equals 1, that would be 2 times 1 is 2 plus 1 is 3. So we come up here from 1, we come up to 3, which of course is midway between 2 and 4. And then we want to have a straight line that has a slope of 2. And the best way to do that, I think, is just to find some other point of the line and then join the 2 points. And so I came over here to t equals 3. When t is equal to 3, we have 2 times 3 is 6 plus 1 is 7. And so you can see I came up from 3, came up here to the point, and I tried to come up to the point 7, which is, of course, halfway between 6 and 8. And so then I joined these 2 points I know, 1, 3, and 3, 7. I drew the blue line through those two. And of course, it would keep on going forever because this is the expression for all t greater than 1. So the blue line shows you what x of t looks like. Now let's think about x of 2t minus 3 in the red. Okay. So up here, we see that that is going to be equal to 0 for t less than 3/2. And so you can see here how this red line is at, it stays constant and equal to 0 until we get over here to t equals 3/2, which is, of course, 1.5. Then, between 3/2 and 2, it's equal to 1. So from 3/2 to 2, you can see the red line is constant and equal to 1. And then finally, for t greater than 2, the expression is 4t minus 5. So the way that I figured out how to draw that was, okay, I said, well, at 2, that would be 2 times 4 is 8 minus 5 is 3. So I came up here to the point 2, 3, and so I started right there. And then again, just as with the blue graph, I wanted to find one more point so that I could, draw a straight line. I can see that I want a line of slope 4 here, but to help me draw that, I want to find one more point. So again, I just came over to t equals 4, and t equals 3, and 3 times 4 is 12, minus 5 is 7. So actually, at 3, 7, the red graph also goes through that. And so I've extended the line, and the red graph would also go on forever. And you can clearly see that the red graph has a steeper slope than the blue graph. And that's also clear from the expression, because here the red graph for t greater than 2, it has a slope of 4. But the blue graph for t greater than 1, it has a slope of 2. So this red graph represents the function x of 2t minus 3. And so if we try to summarize what has happened as a result of changing the argument of the function x of t, we can see that the function has been shifted, and also it has been scaled in time. It's been shifted to the right, and it has also been compressed so that it's rising more quickly. So that is an example of what happens when we change the argument. The 3 here is what's doing the shifting, and the 2 is what's doing the compression. And the book talks more about that and how you can look at the formula and figure out just how much shifting you'll have. But I personally like to use this approach better. But you should acquaint yourself with both approaches and use whatever you like. You just want to be able to understand how to get the expression for a function when the new expression for a function when you change its argument. So I hope that you were able to follow all of that. And the next problem is just a slight elaboration of that. So I hope that what you will do, particularly for this next problem, for the next example, I hope that you will just take a look at the statement of the problem first, and then don't watch anything more. Stop it right after I state the problem and try to finish it yourself, and then compare to what I do. So let's see how this goes. For example 2, okay, you remember in example 1, we started off with the expression for a function. But here it's a little different. We're going to start off with a graph for a function. So here you have the graph of the function x of t, and we want to figure out what x of 4 minus t over 2 looks like. So again, I want to challenge you to try to do this problem on your own. Now, I'll admit that it is, I think it's more challenging than the problem we just did. It's more challenging than example 1. But see if you can try to get this yourself first, and then after you've given it a good shot, then resume the video and see how your work compares to the approach that I will suggest. Okay, so what I suggest doing is the following. As I said already, what's different for this example as compared to our first example is that in the first example we started off with the expression for the function, whereas here we start off with the graph for the function. So it seems to me that the best way to proceed would be to see if we can use this graph to find the expression for x of t. And then if we can do that, then once we have that expression, we can use the same method that we used in example 1. So let's see what we can do. Okay, so x of t. Now, one way you might look at this is you might say, well, how many different pieces of the domain am I going to have to look at? Well, it's clear that x of t has one domain over here for t less than 0, and then it acts in a different way for t between 0 and 1, and there's still another way for t between 1 and 2, another way for t between 2 and 3, and then finally in a final way for t greater than 3. So it looks like 1, 2, 3, 4, 5 pieces to the domain here. And in fact, you can see in the expression here, we do indeed have 5 pieces. And you can go ahead and write down what those pieces correspond to. There's going to be t less than or equal to 0, and there's going to be t between 0 and 1, t between 1 and 2, t between 2 and 3, and then a final region is t greater than or equal to 3. So I think that all of this is pretty easy to understand, but now the slightly tougher part is finding out the expression for x in each one of those regions. So let's see how this goes. Well, the first one is easy. It's clearly the case that x is equal to 0 for t less than 0. So we have that one in the first region. But now what about this next region? What is x equal to here? And I think that the best way to look at it is to say, okay, we have a straight line, so we know that it's going to have some kind of expression like at plus b, where a and b are going to be constants. But what are a and b? Well, you know that a is the slope, and it's actually pretty easy to find the slope, because all you have to do to find the slope is to see how much it increases, how rapidly it's increasing as you go to the right 1 unit. And we see that when we go to the right 1 unit, this is increasing from 0 to 2. So if it goes up 2 units, when you go to the right 1 unit, then the slope is 2 divided by 1, or 2. So this will be 2t plus something, again, because this slope is 2, this is going to be 2t plus something, and that something that you need to add to it is actually 0, because remember, the 2t, let's call it 2t plus b. Okay, the expression 2t plus b needs to agree at both endpoints of that line. Well, if 2t plus b is equal to 0, when t is equal to 0, that would tell you that b must be 0. And similarly, if 2t plus b must be equal to 2, when t is equal to 1, that as well would tell you that b must be 0. So whichever endpoint you look at, you conclude that the expression should be simply 2t. And again, notice that 2t agrees exactly with the two endpoints. 2 times 0 is indeed 0. 2 times 1 is indeed 2. So 2t is the expression for x when t is between 0 and 1. Now, we go to the next one, t between 1 and 2. And this one's easy because x is constant there and equal to 2. So we can just write down 2 for t between 1 and 2. Now, let's see what happens for the next region when t is between 2 and 3. Okay, so again, I will take the approach of trying to find the slope first. Again, this is a straight line, so the expression for it should be at plus b, where a is the slope of that line. And if I can find the slope first, then it's usually going to be pretty easy to find b. So let's see if we can find the slope. And we're going to do it the same way as before. We say, okay, if we go to the right 1 unit, how much do we increase? Well, when we go from 2 to 3, this increases from 2 to 6. So it increases by 4 units in the vertical direction when we increase by 1 unit in the horizontal direction. Therefore, the slope is 4. So we are looking for an expression of the type 4t plus b, 4t plus b, between here and here. And to find b, we can check that at either endpoint. Okay, so in other words, let's check here. 4t plus b evaluated at t equals 2 would be 8 plus b, and we want 8 plus b to give us 2, because the value of the function at t equals 2 is 2. Well, if 8 plus b is equal to 2, b must be negative 6. So we have down here 4t minus 6. Now we could have come up with that same result looking at this endpoint of the line. Let's see how that would go. Again, we know, because this slope is 4, we know that we're looking for an expression of the type 4t plus b. So let's try to find b by looking at the right endpoint of this line. Okay, 4t plus b, when t is equal to 3, 4t plus b would be 12 plus b, 12 plus b, and what should 12 plus b be equal to? it should be equal to 6. Well, if 12 plus b is equal to 6, what's b? Once again, we conclude b is equal to -6, same as before. So either way you look at it, you conclude that the expression for the function between t equals 2 and t equals 3 is 4t minus 6. And I want to emphasize that this expression agrees with the values given at both endpoints of this line. When t is equal to 2, we get 2 times 4 is 8 minus 6 is 2. So 2, 2. And when t is equal to 3, we get 3 times 4 is 12 minus 6 or 6. And a 3, 6. So 4t minus 6 is indeed the correct expression for this line segment right there. And that's the expression we have for t between 2 and 3. And then finally, when t is greater than or equal to 3, well, it's easy again. X is just constant and equal to 6. So now we have our expression for x of t. And now that we do have an expression for x of t, now we can use the method of example 1 in order to finish this problem. So remember, what we want to find, now that we have x of t, our goal is to find x of 4 minus t over 2. And so everywhere we see a t in this expression, we want to replace it by 4 minus t over 2. So let's see how that will go. Okay, so we replace this we replace this t in the argument by 4 minus t over 2. We replace this t by 4 minus t over 2, 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 and this t by 4 minus t over 2. And then in the actual definition, okay, the 0 comes down as 0. 2 times t becomes 2 times 4 minus t over 2. The 2 just comes down as 2. 4 times t minus 6 becomes 4 times 4 minus t over 2 minus 6. And the 6 just comes down as 6. Now, as before, we want to start simplifying things. And we want to both do some math over here to make these definitions simpler, and we want to do a little bit of algebra here, or excuse me, a little bit of math here in order to get all of these domain definitions in terms of t rather than in terms of 4 minus t over 2. So let's see how this will go. The 0 becomes 0. 2 times 4 minus t over 2 becomes 2 times 4 is 8, and 2 times minus t over 2 is minus t. Notice on the left-hand side, we just bring down x of 4 minus t over 2. This 2 comes down as 2. 4 times 4 is 16, minus 6 becomes 10, and 4 times minus t over 2 becomes minus 2t. And we bring down to 6. So that simplifies everything here on the left side of the bracket. And then we bring down the word 4 in each case. And now we want to do some work over here on the right side of each bracket. Okay, so again, remember our goal is to get everything in terms of t. So the first thing that seems like a smart idea is to, up here, we will add -4 to each side of the inequality. And likewise, we'll want to do that here, and here, and here, and here as well. In each case, we're doing that because the 4 minus t over 2, if we'll add -4 to that, then we get rid of that positive 4, and we're only left with minus t over 2. So that's the reason we're doing this. And remember, since we're simply going to be adding -4, since we're adding a number to both sides of the inequalities, that's not going to change the sense of the inequality. So when we add -4 to both sides of this inequality, -4 plus 4 minus t over 2 simply becomes minus t over 2, and -4 plus 0 becomes -4. When we add -4 all the way through this equality, okay, the 0 minus 4 becomes -4. -4 plus 4 minus t over 2 is just minus t over 2. And -4 plus 1 is -3. -4 plus 1 is -3. -4 plus 4 minus t over 2 is just minus t over 2. -4 plus 2 is -2. -4 plus 2, -2. -4 plus 4 minus t over 2 is minus t over 2. -4 plus 3 is -1. And then in the last line, -4 plus 4 minus t over 2 is just minus t over 2. And -4 plus 3 is -1. And again, notice that all the inequalities, I have brought them down just as they are. I haven't changed anything. I haven't changed the sense of any of the inequalities because, again, all we're doing in going from here to here is adding through a -4 everywhere. And when you add to both sides of an inequality, that does not change the sense of the inequality. So this is where we are at this point, and I think it's clear that we have made a lot of progress. Everything here is as simple as we could really get it, and everything here is as simple as we could get it. And even here, we have made a lot of simplification relative to what we have up here, but we still don't have everything in terms of t. We instead have everything in terms of minus t over 2. But we can correct that. Maybe I shouldn't say correct that. Let me say remedy that. We can make the progress and get everything in terms of t by multiplying by -2. Because in each case, we presently have minus t over 2, but if we multiply by -2, then we'll simply have t, which is what we want. So we need to take each one of these inequalities now and multiply through by -2. But remember, since we are now multiplying through by a negative number, that will switch the sense of the inequality. And it's really crucial that you remember that in any problem like this. Otherwise, you'll mess up. So remember, when you multiply both sides of an inequality by a negative number, you need to change the sense of the inequality. Okay, so in coming from here, from this step down to this step, everything over here, we just bring it down, and then when we multiply through by -2, this becomes t. On the left-hand side, all the negative t over 2's will just become t. And then -2 times -4 is 8. -2 times -4, 8. -2 times -3, 6. -2 times -3, 6. -2 times -2, 4. -2 times -2, 4. -2 times -1, 2. And -2 times -1 is 2. And so there we have it. Here is our final expression for x of 4 minus t over 2. In fact, it's not a big deal, but I'd like to have that circled, so give me just a second. Okay, let's see. I've circled it on another computer, and let's see if it will. It hasn't refreshed yet. There we go. Okay. Like I say, it's not a big deal, but just to be consistent. So there is our expression for x of 4 minus t over 2. And even though you weren't really asked to do it, I think it is instructive to graph that. And so in green, I have graphed the original function x of t. And in red, I have graphed, in blue, I have graphed x of 4 minus t over 2. And I think it's pretty clear how to graph x of t. The expression for x of t is up here, but let's make sure that it's clear how we're graphing x of 4 minus t over 2. So this is in blue. Okay. So we're going to look at the blue graph now. Not the green graph, but the blue graph. This is the graph of this is the graph of x of 4 minus t over 2. Okay. So it says that it's equal to 0 for t greater than or equal to 8. So you can see here this portion of the graph, once we get out here beyond 8, is equal to 0. So it would be 0 forever after 8. Okay? Now, for t between 8 and 6, it's equal to 8 minus t. Okay, well, let's think about that. At 6, 8 minus t is equal to 2, and at 8, 8 minus t is equal to 0. So we just have this straight line joining the point 62 to the point 80. You can see that this has a slope of -1. You can see it from the expression right here, or you can see it from here, because as we go over 2 units to the right, we've also gone down 2 units. Remember that the vertical scale is 2 units per line. So we, as we go to the right 2 units, we go down 2 units. So the slope is -1, which is consistent with 8 minus t. Okay, then it's equal to 2 for t between 6 and 4. And you can see that between t between 6 and 4, it's constant and equal to 2. Then for t between 4 and 2, it's equal to 10 minus 2t. So it has a slope of -2, and we can see that that looks like indeed a slope of -2, but we'll check it. And the expression is 10 minus 2t, so let's check it. Let's check it at both endpoints. At t equals 4, 10 minus 2t would be 10 minus 2 times 4, or 10 minus 8 is 2. And indeed, 4, 2 is correct. And on the other hand, at t equals 2, 10 minus 2t would be 10 minus 2 times 2, or 10 minus 4 is 6, and indeed 2, 6. Okay? And then finally, for t less than or equal to 2, forever, it will be equal to 6. And so as we go on forever in this direction, it would be equal to 6. And so if you compare now the blue graph, which is the graph of x of 4 minus t over 2, with the green graph, which is the graph of x of t, we see that several things have happened. It's been shifted, and the shift is coming in because of the 4. It has been reversed. In other words, the graph where it was small before, here it was going to 0 in the negative direction for the green graph, and here it's 0 in the positive direction. And likewise, this one was non-zero and equal to 6 in the positive direction, but the blue one is non-zero and equal to 6 in the negative direction. So we see that the graph has been reversed, it's been shifted, and it has also been expanded. You can see that the slopes are now less than they were before. The slope right here is less than the slope here, and the slope right here is less than the slope right there. And the reversal is coming in because of this negative sign in front of the t, and the expansion is coming in because we're multiplying t by 1/2. You get expansion when you multiply t by a number that's less than 1, a number whose magnitude is less than 1, and you get compression when you multiply t by a number whose magnitude is greater than 1, and you get reversal when you multiply by a negative number. So that's our discussion on some of the things that we can do with signals, and I hope that will clarify some of, or maybe I shouldn't say clarify, but give you a different way of looking at some of the things that appear in the first 2 sections of the book. And so now I hope that you'll be in good shape to do daily test number 1. Thanks, and I'll talk to you soon.